All right, guys. Now that you've gotten to know what elements are and a little bit about the periodic table, I'm going to take you through some of the important groups and trends in the periodic table, and then you'll do a little bit of work on that. All right, so let's do this elements in the periodic table. So, what the table is, it provides an arrangement to elements which allows us to explain and predict their physical and chemical properties. So what happened was when they discovered a number of elements, which they decided were elements because they couldn't break them down any further. So we're talking hundreds of years ago here. Just Google image a picture of Dmitry Mendeleev, and he's the guy that kind of came up with what is now the modern periodic table. When they ordered these by atomic mass in these groups in periods, then they found that they could predict what the chemical and physical properties would be of ones that were close together. They could predict what would happen across the rows and down the columns. Generally, pairs of elements from opposite sides of the table react to form compounds. So, what that means is that lithium reacts really well with fluorine, and sodium reacts really well with chlorine. Now, they don't have to be in the same level there, just basically everything from what let's call group 1 reacts really well with everything from group 17. That's the way that it goes. So that's what we mean by that. As discussed last time, metals are on the left side. Examples: sodium, potassium, magnesium. Nonmetals are generally on the right side. On the other, the top right. Beyond that staircase divider, carbon, oxygen, fluorine, chlorine. And the exception is hydrogen, because if I just go back a slide here, you see where hydrogen is, element number 1. It's very special. It is actually technically a non-metal, but the way that its electrons are arranged, and we'll learn about that a little later, puts it into group 1. All right, so it's just a weird sort of exception. The metalloids is a goofy name given to the ones that kind of go right along that staircase line. And sometimes they can behave like metals and sometimes they can behave like non-metals. So, it's not really, I guess what that means is it's not a straight cutoff where everything acts like a non-metal on the right and everything acts like a metal on the left of that line. The things that are right around that line can exhibit properties of both. Like, well, you can see the ones that are in green there: boron, silicon, arsenic, etc. So let's talk about chemical families. Elements in the same column, not row, but column, belong to the same group or family. So when you say they're in the same group, the same family, we're talking columns. All right. So on the first slide there, where I was saying group 1 and group 17, those are the same family. They share the same physical and chemical properties. So they behave the same. Let me give you an example, and I don't know if it's going to come up later. All these guys here in group 1, with the exception of hydrogen, those guys right there, they are the alkali metals, and they all react really violently with water. So these are shiny, fairly soft metals. You put them in water, they react very quickly, very violently. One time I even put a hunk of potassium into a beaker of water in front of a class when I was a newer teacher, and it jumped right out of the beaker on fire and caught some kid's textbook on fire. It was quite a scene. Anyway, I didn't do that one again. Like I said, oh yeah, here's the alkali metals right here. Group number 1, lithium, sodium, potassium. If you were to go on YouTube and search for, I think it's Brainiac alkali metals, then you get a good, they do some good demos of putting some of these more dangerous ones in water. So they're shiny and soft just means like malleable. It doesn't mean they're soft like, petting a puppy here. It means they're soft, that you can bend them and change their shape and they don't break. Highly reactive metals. Valence electron of +1. If you're taking notes here, write that, even though you don't really need to know what that means yet. Group 2, the alkali earth metals, magnesium, calcium, and barium. And there's more than that. Those are just three examples. They're all shiny and silvery, not as soft, not as reactive. Mind you, they still are reactive. They still even will react with water, but not as violently as group one, not as violently as the alkali metals. Number of valence electrons for them is 2. The halogens, and I know it looks like we're taking a big jump, and we are. We're skipping that whole group in the middle, and we'll talk about that later. But we're jumping all the way to the other side to group 17. And if you're following along in your periodic table for some reason, then it's the second to last group, the second to last column on your periodic table. Look for fluorine, chlorine, bromine, iodine, etc. They are poisonous, highly reactive nonmetals. Chlorine gas was used as a weapon in World War One, and it would react with people's lungs when they breathe it in. And it was either I can't remember if that's the exact one they used as mustard gas or not, but anyways, it's not good. It's not good. Very reactive, and they have a valence electron. They gain a charge of -1. I don't know if I like the wording of that. As a matter of fact, if you're taking notes, please don't write that. If you are, then you can say the valence electrons are actually 7. So I don't like that line right there. Right beside them is the noble gases. Noble gases, helium, neon, argon. So I'm talking the very last column now. And they're colorless, odorless, tasteless. They can glow when you pass an electric current through them. And that's where you get your neon signs. I've got one out in my garage. They are very non-reactive. That's actually their special property, is that they're extremely non-reactive. You can say that their outer orbital is full, but we're not talking about how their electrons are arranged yet. So don't worry about that. Write it if you want. Don't write it if you don't want. But they are very non-reactive. They don't like to react with anything. You might have thought, well, you said on opposite ends of the table, they like to react with each other. Yes, that's true for everything except for the noble gases. They don't like to react with anything. And we're not going to look at the video right now, but if we we're going to do this in class, then what I would do is I would show you magnesium and calcium and what happens to them when they react with hydrochloric acid or with water. And then these guys are all in group 1. They react violently with water. But if you were just to YouTube lithium and water, sodium and water, potassium and water, there are good videos on that. So now let's talk about the rows. Elements in the same horizontal rows show some trends of increasing or decreasing reactivity. For example, like we already discussed, the alkali metals are more reactive than the alkali earth metals. Sodium more reactive than magnesium. Those rows in the periodic table are called periods. And let me just jump back all the way to that first slide right here. So that's a group, right? Group 18 there, that's this guy right here. That's the noble gases, right? So those are the groups. And then these are called the periods. All right, so period 1, 2, 3, 4, 5, 6, 7. Group 1, 2, then it goes 13, 14, 15, 16, 17, 18. Which I'm not going to write all those numbers on there right now, but that's how those are numbered. Now let's skip way ahead to where were we? Talking about periods. And then there's that name again. And if you want to see a guy that looks a little bit disheveled, Dmitry Mendeleev, 1869, that's kind of the father of the modern periodic table, I suppose, a Russian chemistry professor. If you Google image him, you'll see a guy with a big squirrely looking beard. As a matter of fact, since I've been cooped up in my basement for months, I look a lot like him right now. So it'll be like looking at me. At that time, there were only 63 known elements. He arranged them by their masses and noticed that certain elements had similar physical and chemical properties. He also predicted where there were missing elements in the table, and they were later discovered. And that was one of the big successes of that periodic table. Now, one thing I don't have mentioned in this PowerPoint is what about the middle? I don't know. Nobody jumped up and shouted out that we skipped this big group in the middle. And it does say what they are. If you read this, they are the transition metals. So they're all metals, and a lot of them do share the same sort of properties. But since moving forward in grade 9 and 10 chemistry, we do very, very little with the transition metals, other than there's a few important ones that you have to remember, like copper, nickel, iron. There's a few special ones that we use quite a bit. Zinc, I think, too. I'm just kind of looking through it really quickly to see if there's any big ones. Mercury's fun just because it's a liquid at room temperature. But other than that, we don't really mess around with them very much. These guys down here are the rare earth metals, the lanthanides and actinides. And I don't know how much we'll need, other than needing to know what they are and where they are on the periodic table. You don't need to know that much about it. Anyway, that is the end of that PowerPoint. I have questions posted as well. Let me just see if I can bring them up for you guys, just to give you a heads up of what you're up against. Periodic table, the elements, here it is right here. So what I think you're going to have to do is very quick, like, I'm not saying read the whole section, but look through it and see if there's anything that we forgot to go over, okay? And then just answer questions 1 to 6 on page 225. What else did I want to say here? There is a 21-minute, just an optional. Now, this is an old school chemical families video. You see down there where it says YouTube 21 minutes. It's a 21-minute video that was shot like before I was in school. So it's an old school chemistry teacher reacting different things in the chemical families to see how they're alike, to see how they're different. So if you're interested, certainly, if you want to see these things in action, what they look like and how they react, then go right ahead and watch that. But it's totally optional. What I want you to do for sure after this is glance over the section if you think you need to, and then go to the questions at the end. And I just want you to submit a picture of those questions at the end, all right, once you're done them. If it'll come up, and maybe it won't because my internet's going kind of slow today. Oh, there they are. So I think it said just 1 to 6. I picked out those questions last week. I can't remember exactly why I stopped at 6, but that's going to be good enough for now, okay? So that is it until Wednesday. And then on Wednesday, well, you can see here it's going to be something on theories of the atom. So how did they come up with this atomic structure, the whole protons, neutrons, electrons, our modern view of the atom? How did it come to be? What were some earlier models of the atom? And how do we know what we think we know? All right, that's going to be it for now. Good luck. Keep the emails coming if you have any questions about anything. All right, guys.